Hello, I'm Neil Turok, physicist. That's a tough act to follow, but I'll do my best. So, what I'm going to talk to you about, if I can get this to work, I'm a theorist. I'm going to talk about physics and our future. As well as being a physicist, I happen to lead the most exciting physics institute in the world, the Perimeter Institute, here in Canada. And what is physics? Well, physics is knowledge of nature. But it's not ordinary knowledge. It's precise, mathematical, trustworthy knowledge. And by nature, we mean more than what most people think of nature. We mean the whole universe. The history of human society has to a large extent been driven by the discoveries made by people, of profound mathematical laws which govern the universe. From numbers used first in the Congo 20,000 years ago, to geometry, to mechanics, to electromagnetism, to particles, quantum theory, and relativity. These discoveries underpin every single technology which we now depend on. From plumbing to planes, from smartphones to satellites, the root of innovation has been our astonishing capacity to understand, make sense of, and use the properties of our universe. For physics, these are very exciting times. We've just seen the results of the largest ever microscope, the Large Hadron Collider in Switzerland, and the results of the most powerful ever telescope, the Planck satellite. They've revealed to us the structure of the universe on scales 1 billion times smaller than the size of the atom. And what we've discovered is the Higgs boson, predicted by theorists 50 years ago. That tells us something about who we are and who we can be, that we can understand the universe on scales unbelievably remote from the everyday world. And the Planck satellite showed us the whole universe, 14 billion light years across, 10 trillion times the size of the solar system. And what do you know? The picture was what we expected, according to the simplest models we had come up with for explaining the emergence of the universe from the Big Bang. And so what we've learned is that on the very biggest and the very smallest scales we can access, the universe is unbelievably simple. This simplicity is a clue as to the nature of the universe, what ties it all together. We're still trying to unravel that clue. But even more exciting than learning these profound truths about the universe, on everyday scales, we're learning that reality is more interesting than we thought it was, and we're learning to manipulate and engineer the quantum world. So let me explain what that means. Based on the discoveries of physics in the early 20th century, physicists invented the transistor in the 40s. And starting around the mid-60s, transistors were shrunk to smaller and smaller sizes. A transistor is just a tap. It's a way of controlling the flow of electricity very precisely. But when you can do that, you can make devices more and more powerful the smaller and smaller the transistor becomes. So right now, we can fit about 10 billion transistors, 10 billion taps, if you like, onto a chip. And on the basis of this exponential growth in the power of electronic devices, a whole industry, a $10 trillion industry, has been built, the information industry, and it's led to what we call the digital age. Well, all of this is set to come to an end because the size of a transistor has shrunk so small it's approaching the size of the atom. And so roughly 10 or 20 years from now, the digital age will be over. We won't be able to treat the world as a digital computer because it is not. The world is much more interesting than that. The world is quantum. So just as the digital age is ending, a new age is dawning. And it's based on the universe. It's based on the most bizarre, strange properties, which we find it most difficult to get our heads around. So to try to describe this, let me compare a bit, the smallest unit of information in a digital computer, with a qubit, the smallest bit of information, the smallest piece of information in the quantum world. A qubit can be carried by a single particle, like an electron or an atom. Well, a bit is just 0 or 1. And that doesn't sound so exciting. But 2 bits can be in 4 states, and 3 bits in 8 states, and 4 bits in 16 states. And the more bits you have, the more information you can store in them. And it grows exponentially. And that's why the digital age has created these huge means of processing and conveying information. It's exponentially powerful. But the smallest ingredient, smallest element of the quantum world is a qubit. And a qubit has an infinity of states because things can be 0 and 1 at the same time, and because they involve a bizarre number called the square root of -1, the imaginary number, which actually is at the heart of the quantum world. So this tiniest thing in the quantum world contains an infinity of information. And if you put 2 of them together, you get infinity squared, and 3 of them infinity cubed, and so on. And it's pretty hard to get your head around. But the fact is, this is coming. In the last 2 or 3 years, we've seen an absolute transformation in our ability to access and manipulate the quantum world. We're seeing quantum sensors, which can detect organic molecules non-invasively without disrupting them. We've seen quantum communication channels, which are absolutely secure, cannot be eavesdropped according to the laws of physics. They're protected by the laws of physics. And finally, we're seeing quantum computers, which will make our so-called digital revolution look tame. As we reach closer to the true nature of reality, these quantum technologies are going to revolutionize our world and our society. There will be vast opportunities for industry and for education. Thanks to physics, we have an amazing future to look forward to. Thank you.